Yeah, hello together. I'm Helmut Biechmann, responsible in our company Coroplast for the global product management in the business unit wire and cables. I'm proud to present today, in the next couple of 10 minutes, not more, our thinking, daily activity, and so on regarding the sub-project number 4. As Wolf and Carsten already explained the development process, how we create requirements in the new DIN standard. In our SELS, every project partner is very active. We create proposals, and this kind of proposals are discussed and finalized in the DIN working group 51. And here we make it final for the for the standard. Our project partners are well known. Our projects, low voltage harnesses already explained, low voltage connectors already explained. Thank you so much for the information to the core team. Currently, I will inform you to the sub-project number 4 for the HV harnesses, called automated processing of HV harnesses. Our project partners in this team are car manufacturers like BMW and Mercedes-Benz, harness maker Lear SEA, supplier for processing equipments, Comax, specialized for ultrasonic welding machines, Talsonic and Schunk, and as well component suppliers for connectors, Rosenberger TE and Costal, and for protection systems and wire and cables, Coroplast is available in this sub-project number 4. Our daily working is to extend the content of the standard 72 or 63 with requirements for the high voltage harnesses, for production processes of harnesses, for the harness designs, and as well its components, use components in this kind of harnesses, for connection system, cable, mountain parts, and so on and so on. Our daily planned results is extension of the chapter number 3, terms and definitions for the HV vocabulary, checking of new design rules from other projects, as well creating own new design rules, depending on thinking about HV distributors, and as well how we can mount HV connector on the HV cable, thinking HV harnesses is point-to-point connection, and the middle of the connection is a HV cable, left and right side is a HV connector. And this is best information to understand. It must be worked not manually by hands, it must work automatically in the production lines in the future. As well, we have to update the chapter number 7. Mr. Bös informed you already about the DDA, currently based on low voltage harnesses. As well, we made an update for HV harnesses. Have a look to the current version number 2, available since March 26, at first in German version. English version will come. The structure of this standard shows you a lot of information, terms and definition, and so on. I will follow slides based on design rules. But design rules are created for harness concepts, usable for car manufacture, harness designs, usable for car manufacture and as well tier 1s, usable for manufacturing processes, usable for the equipment supplier and as well for the tier 1s, and for the tier 2s, components, HV components suitable for the automatic production, usable in HV harnesses. If we compare the first edition of the standard with the second edition and the coming third edition, depending on the structure or the chapter of the standard, depending on design rules for wiring harnesses concepts, wiring harness designs, wiring harness manufacturing processes, and for the components. It's clear visible in summary the increased numbers of design rules. And as well, it's not very surprise for all increasing of design rules for the components. Remember, beginning version 2, second edition, we added the application of data transmission cable, radio frequency cable will follow in sub-project number 5. And as well, we added our activities here in HV harnesses. And the design rules of the components will increase more and more. And we see the current situation, more than 100 design rules currently in discussion. End of the year will, I'm sure the figures of design, the number of design rules will increase a little bit more. If you have a look to the design rules for the components, we have to make clear we have different kind of components: mounting parts, sealing elements, terminals, connectors, HV connectors, and as well electrical cables. And here in this part or sub-project number 4, it's only a high voltage cable. And in our discussion, we added every HV single core cable, multi-core cable, unshielded cable, shielded cables, copper cable, aluminum cable. In the scope, we discussed conductor sizes 2.5 square up to 120 square. The current situation. We not included currently in the scope the coming bus bars caused by the situation. Bus bars complete, depending on standardization requirements. It's a complete new component for the automotive industry, and the standardization of the component is starting international. And we decided we are waiting for finishing of the standard of the bus bars, and then makes sense to create requirements or to add and discuss about automatic processing of this kind of bus bars, only for the information. Comparison of design rules in detail: mounting parts, sealing parts, terminals, electrical cable, first edition, second edition, third edition. Clear visible increasing of requirements for the connectors, HV connectors. That means in the past we focused our activities in the last 6 months, depending on the connectors. Currently, we are in discussion about cables and as well connectors. Yeah, some impression to see you only a couple of design rules here for cables. Thank you so much, Jens Hauen, for explanation about the low voltage connectors. Here, some explanation about simple design rules for cables. Very easy, but not required for every specification, is the define of the stranding color sequence of sheeted multi-core cables. Have a look to the equipment supplier, the view of the equipment supplier or T1 is makes sense to require to create a rule how to define the color sequence of the stranding multi-core cable in the delivery status. Most times the cables are prepared with rotating knives or rotating knife technologies, and here it makes sense to be focused in the discussion about round surfaces, not only for the outside of the cable, as well for every components and the inside of the cables. And here in multi-core cables, we discussed about rectangle surfaces, and rectangle surfaces are not easy to process with rotating knives for the automatic processing. And we require here please be so kind and use HV cable with circular contact surfaces here, for example, for the shielding braid. If we want to have round cable, sometimes we find cable in the market with separate fillers, but handling of separate fillers, elimination of separate fillers of the cable is only manually processed, not easy for automatic lines to eliminate this kind of fillers. That means please be so kind and don't use this kind of cable. These kind of cable are very easy to process. Automatic processing means a little bit make it easy. Easy cable are easy to process. If we combine here, for example, HV application and low voltage application, here, for example, it's an interlock element into the cable. So processing of this kind of cable is very uncomfortable and very complex. Our requirement here, please be so kind and use only HV cable without integrated HV cable to make the cable easier, to make it easy for the equipment supplier to processing these kind of HV cables, the needed HV cables. Yeah, short outlook to the next timelines and meetings. From the cable side, here's in conclusion, from the view of the bird, we are focused on laser reprinting of HV cables, doing the processing of the cables. It's by the T1s, shielding parameter, tolerances, overlay, sensitivity, and variance of conductors. It's our core topics for the HV cable. Little bit similar to the HV connectors, variance, complexity, sealing designs and tolerances, and as well laser reprinting and shielding process. A little bit visible shielding both sides, processing of shielding. It's not easy for the machinery. By hand, it makes more fun, but our goal is automatic processing here. Some detailed information, laser reprinting. It will come that a car manufacturer will require to add data matrix code on the harnesses. Here, for example, on the HV cable. HV cables produced by the cable supplier, they print the text with inkjet printer, but HV cable are not really good depending on the due to the electrical performance of the cable, to print this kind of data matrix codes by those tier ones. And as well, we need a lot of contrast here for the data matrix codes. Makes sense to look about laser technology, makes sense to print this kind of data matrix codes with laser technology. Deep look, here we figured out 3 different kind of laser technology: CO2 laser, fiber laser, and UV laser. We started separate R&D projects in our sub-project regarding this point laser reprinting. Finished an investigation based on 3 suppliers for laser technologies, thanks to Domino, Keyence, and as well Comax. With Domino, we make tests with all 3 technologies. With Keyence, we focused on fiber and UV laser, and Comax only UV laser. Current results not finalized, analyzed. Core information here is we found generally positive results over all parts we printed. It was flower troughs. We tested more than 20 test parts. Best results with UV laser technology. Makes sense to think about if the harness maker in the future will invest in UV laser technology, and he must print orange cable. Orange cable means HV cable. Makes sense to think about a UV laser. And I'm sure today with our information, without any addition of any chemicals in the cable, additives and so on, the most cables are printable with UV laser without any addition of additives on the cable. Not currently not finalized is the decision: do we create a design rule or more than one design rule in our standard, or do we figure out a white paper? It's finalized to figure out a white paper to public all information. Very interesting information. Design rules is not finished here. Regarding core informations about the cable side, from the cable side, we figured out different kind of current requirements in different kind of standards, car manufacturer standards, national standards, international standards, and we compare this kind of requirements, available requirements compared to needed requirements. And that is our daily working to figure out, make sense to add further requirements into the version 3 of the standard. Currently, we are focused on the third version of the standard. Version 1 is finished, version 2 is finished, version 3 will come. Thank you so much for your interest. If you have any question, ask now or later. Thank you so much.